Hi everyone, this is Vibhav. Welcome back to the channel. So in the last video we were looking at this very interesting plot on Desmos, in which the limits seem to be going to the square as n tends to infinity for this x power n plus y power n equals 3 or any number on the right hand side. So let us see where the catch in this is. So as far as I keep putting even numbers, there's no problem with this. If I put 4000 or if I just put 402, if I put 488, nothing seems to be wrong. But the problem is when I put an odd number for n. Now look at this. This in no way seems to resemble a square. In fact, it doesn't even appear to be a closed curve. So what exactly happened? You see, in the first quadrant there's not much of a deviation from the usual behavior, and that's because when we take x power n and y power n, and when we take positive numbers and power them to n, they're anyway going to be ending up positive. So when x and y are positive, it shows a given behavior for both odd powers and even powers. But when you take the second quadrant where x is negative and y is positive, you can see that when you take it to an odd power, this x power n term starts to decrease the overall value and y power n term starts to increase the value. So as we go towards the left, when you increase x power n becomes increasingly negative, and when you take this x power n to the other side, you get y power n is 3 minus x power n, which turns out to be a positive number. It just has to be, since y is positive over here, so y cube is obviously positive. So what happens is that this curve starts to go upwards. It starts to become an increasing curve when you look at it from 0 to minus 2. In that sense, in the negative x sense, this starts to increase. A similar thing is seen in the fourth quadrant, and also in the third quadrant this curve doesn't exist at all, because there's no way you're going to take two negative numbers to an odd power and then add them and get a positive number. Let's look at another nice case where n is 3 by 2. So in this case you can see that the curve exists only in the first quadrant. It can't exist in the second or in the fourth quadrants, since you are taking x power 3 by 2 and y power 3 by 2, which is nothing but root x cube, and root x exists only for a positive x, and the same way root y exists only for a positive y. So for this curve to exist, you've got to have both x and y positive, so this exists only in the first quadrant. So if I consider this kind of square root to the power of a natural number sort of ways for writing this x power n plus y power n equals 3, I could make it, let me say I make it 1999 by 2. This starts to resemble a fourth of a square, that is the part of the square that should have been there within the first quadrant, but you can see that the second, third and fourth quadrant aren't helping us at all in this case. So what happens is, when we take the power to be an odd number and then take the limit of n to be infinite, a limit of n tending to infinity, we make the curve starts to go outwards in both the second and the fourth quadrants. So this doesn't allow us to give it that limit exactly. So what we could say is that for an even number n, as this even number n is going to infinity, we get a square, but that itself is not a very good way to define this, because infinity is more of an idea than a number, and assigning infinity to be even or odd itself is something we need to really think about, because in this case we are calling some infinity and calling it a natural number, which is not exactly how we deal with infinities. So to conclude, there are two messages out of this. The first one is to make everyone understand that visually looking at math is a really good way to learn it, and the second is to show how wonderful a subject calculus is, especially limits.